Today we are going to discuss crystal field theory in coordination chemistry. This topic is very important topic. So let's start. What is this crystal field theory? This is known as CFT, right? Crystal field theory. CFT. Okay. So after VVT, actually VVT has some limitation. So this crystal field theory came. So directly we are going to discuss crystal field theory. We are not talking about here what is the limitation of VVT and all these things. Okay. So in this crystal field theory, this theory consider all that ligand and that metal. Okay. Metal and ligand again both are considered as point charge. Point charge. Okay. So here this metal charge plus that's plus an okay, this metal charge considered as stationary charge that is not moving charge. Okay, and this ligand charge considered as moving charge. Okay, now see, and here the interaction is the interaction between that metal and ligand is known as electrostatic interaction. Okay, here the interaction between metal and ligands are electrostatic interaction. Okay, now see, according to CFT. Okay, according to CFT. Okay, the tetrahedral complex, metal ion is present in tetrahedral voids formed by ligand. Okay, in tetrahedral complex, okay, metal ions present in tetrahedral void that is that is formed by ligands. Okay, similarly in octahedral complex, here also metal present in octahedral void that is formed by ligands. Okay, now one by one we will discuss about this tetrahedral complex and about this octahedral complex. How can this tetrahedral and octahedral complex can be explained by this CFT. Okay, first we are going to discuss about like octahedral complex. Okay, so put the heading that is formation of octahedral complex. Formation of octahedral complex according to CFT. Okay, put this heading. Okay, now see, Actually, what happens? See here. Okay, I'm explaining this in 3D. Okay, see, I'm drawing a cube here. Okay, see now what happens here. This is your cube. Okay, see here in this cube we have six faces, right? This is one face. This is another face. This is another face. This is another face, and this front one is the one face, and the back one this is the another face. Okay, so in this formation, actually see uh, in octahedral complex we have coordination number is equal to 6, right? That means here six ligands approach from this six corner, not six corner, that is six faces, right? Yeah, this six ligand that approach from these six faces. Okay, that is the main thing here we have to understand. Okay, here the six ligand that approach from six, here this ligand from this face, right? And here this ligand from this front face. Okay, understood or not? Now see what happens, and we know that here if they will approach from these six different faces, then inside this cube there will be a octahedral void, right? So here in this octahedral void metal is present. Okay, this is your metal. Okay, and we also know that this metal having d orbitals, and here this d orbital having 5, or you can say d subshell, and the d subshell having 5 orbitals. Okay, what are there? That is dxy, dyz, dzx, dx square minus y square, and dz square. These are the 5 orbitals of that d subshell. Okay, and we also know that these three orbitals dxy, dyz, and dzx, that is present in between the axis, in between the axis. But this dx square minus y square and dz square, this orbital present along the axis. Here here this is your orbital, this is your orbital. Okay, which orbital is this? This is suppose dx square minus y square orbital. Okay, dx square minus y square orbital that is present along the axis, okay, this dx square minus y square, and dz square that is perpendicular to this. Okay, perpendicular to this, that is this one. See, this one is perpendicular to this. Okay, this is your dz square. Okay, see what is this? This is dx square minus y square, and this orbital is dz square orbital that is perpendicular to this orbital. Okay, now see, so these two orbital that is that exactly occupies these six faces along which six ligands approaching, six ligands are approaching. Okay, now another these three orbitals, another this three orbital that is present in between the axis, like xy, yz, and zx. Okay, okay, so what happens when this ligand that is approaching from this infinite distance, suppose. Okay, when they are approaching, why they are approaching? Because here inside the metal is there, and that metal is d block metal, and also that contain high z effective. Okay, as this d orbital of this metal that is containing d electron. So after some distance, what will happen, that there will be a repulsion between these d electron and these all ligands. Okay, these d electrons and these ligands, there will be the repulsion. That's why how the splits happens. This is initially, this is the 5 d orbitals that is in ground state. Okay, when when metal z effective is high, that means ligands are approaching. That's why this d orbitals, what will happen, some excitation will happen. That means energy will increase, that is excitation state. Okay, excited state. Okay, now in this excited state, when ligand will reach some distance, then there will be the repulsion between electron of d orbitals and this ligand. Then what will happen, there will be a splitting of this d orbital will happen. So in octahedral field, where ligands approaching from faces, here the splitting orbital will looks like this, the splitting diagram. Okay, so here these two orbital will having higher energy, because because they are repelled by the six ligand that is approaching along the face, that is dx square minus dy square and dz square orbitals. And now these orbital, dxy, dyz and dz orbital, they will lose some elect that what energy, and they will be again their energy will low. Okay, now see what will happen. This center is known as Berry center. That is known as what? Berry center energy. Berry center. Okay, now see this gap. This gap is known as delta O. Del O, that is the energy difference in octahedral environment. Okay, this O represent octahedral. Now see these these three orbitals is known as T2G, and this is known as EZ. That means this d orbital split into two energy level, that is one is T2G, another is EZ. Okay, so what will happen here, that these two orbital, their energy, they repel by three part of this total energy. Total energy is what? Del O. Three part, that means plus 0.6 del O. Okay, and this T2G set decreased by, the energy decreased by, it is minus 0.4 del O, that is two parts. Okay, and total energy gap is del O. This is the splitting in octahedral field.